So this video is on solving rational equations. And so we're going to have an equals involved, and we're going to be actually solving for an x value that will make the equation equivalent one side to the other. And with these big, ugly, nasty fractions, which are the rational part of the rational equations, you want to continue to get a common denominator, but then once you have a common denominator, you want to drop the denominator. But that's only after you have a common denominator. Some of you are going to look at like 1 through 6 and say, oh, I'm going to cross multiply. Or I think in middle school, sometimes they call it butterfly. And that's great, but that's not going to work for 7 and 8. So I'm going to show you the way that I'm going to talk through it, which is also going to work for ones like 7 and 8. But as you guys are going to be able to see, it's the exact same thing as the cross multiply. So for number 1, my common denominator is a 15. So I'm going to multiply one side by a 3 over 3 and the other side by a 5 over 5. And so that's going to give me 18x on top and a 15 on the bottom, and a 10x minus 35 on the top and a 15 on the bottom. And then once you have that common denominator, once the denominators are the same, you can completely drop the denominators and then just solve the top. So I would then subtract 10x from both sides and then divide by 8. The only thing you have to be careful about with rational equations is that your answer can't make any of the original denominators equal to 0. And on number 1, we had a 5 and a 3. It will always be a 5 and a 3, so we don't have to worry about any of those. But let's look at the next one where I think something like that pops up. So in number 2, they already have a common denominator, which is wonderful, and that means we don't have to do a thing. We can just drop the denominators. So that's going to give me 7 equals m plus 4, and then I can just solve, and I get m equals 3. Well, and normally, you know, m equals 3, you box it in and you move on. However, what would happen to the original problem if m was actually a 3? And what would happen is it would make actually both of these denominators equal to 0. And you cannot have a 0 in the denominator. So I cannot keep this solution. And because it is my only solution, that means there are no solutions to this problem. So you just kind of have to stay on your toes with that. Number 3, an x plus 2 and an x minus 5. So I'm going to give this guy an x plus 2 and give this guy an x minus 5. They would have a common denominator then. That would give me 7x minus 35 equals 6x plus 12. I'm already going to go ahead and drop the bottoms because I know they're the same. And then I'm going to subtract 6x from both sides and add a 35. And I get x equals 47. I can't be a negative 2 or a positive 5, so 47 is good. I can keep it. For the rest of these, especially for 4, 5, and 6, I'm not going to go through those because it's the same common denominator stuff that we've been talking about. I do want to point out on number 4 how this denominator is subtraction and it is backwards. So all I'm going to do on this one is throw a negative down on my 3, and that allows me to flip that to an x minus 4, and then they are the same, so I can drop them, and I'll have 5x minus 1 equals negative 3 and just solve it from there. Number 5, you would want a GCF and then realize that he just needs an x minus 2. You would have to lobster that. And then they have the same denominator, so then you can drop it. Now this one is a little bit more tricky because we are now quadratic. And 1, 2, 3, and 4 were not. So now I need to get it equal to 0. So I'm going to subtract the 16 over. Nope. Sorry. And then I'm going to factor it. 4 and 6. So x equals 4 and x equals a negative 6. And I can't be a 0 or a 2. So I can keep both of those. So just, you know, kind of remember all the things. If it's linear, solve it like a linear equation. If it's quadratic, get it equal to 0. If it factors, that's great. You can still complete the square. You can use the quadratic formula. You still have all the tools that have been built over your previous math courses that now, you're expected to have in your toolbox, that you could use at any time. So that's kind of what these videos are to help, is to help kind of brush back up on the tools that should be in your toolbox. So number 7 has 3 different denominators. My common denominator is going to be a 2x, so I'm going to give him a 2 over 2. And that's going to give me 3 plus x plus 6 equals negative 10x minus 24. This is not quadratic, so I'm going to get my x's 9. And then divide. And he's good. I just couldn't be a 0. This one I would put him over 1, multiply him by x. I mean, he's pretty straightforward. Let's see. That one's pretty straightforward. 10, let's look at 10. Excuse me, 10's common denominator is going to be a 6x squared. So the first guy needs an x squared. The middle guy needs a 6 and an x. And the third guy needs a 3. So now I have x squared minus 12x equals a negative 36. I am quadratic. So I'm going to get him equal to 0. And then let's see. 6 and 6. So x equals 6, and I can keep it, I just can't be a 0. So let's see. This guy's a big one. And that one has a shark. So let's do 11 and 13 and 14. Okay, so this is x plus 1, x minus 1. So he needs both. So he's going to get the x squared minus 1. He has both. He just needs an x minus 1. So the top, let's see, that's going to be x cubed minus x plus x squared minus 5 equals, and then I have to lobster this out, so bear with me. X cubed plus x squared plus 2x minus x squared minus x minus 2. Okay, so I started to freak out because I think, okay, I can handle linear, I can handle quadratic, but this guy's cubic, but he's really not, because those two guys are going to cancel each other out. These two x squareds are going to cancel each other out, but then I have this one, so I'm going to add it to the other side. So he's been moved. This and this are a positive x, which I'm going to subtract over to here. And that's going to give me a minus 2x. So that's that, and that, and that, and that. And then I'm going to add the 2. Okay. So there it is, all cleaned up. It's quadratic. I'm going to try to factor it. And I cannot be a negative 1. So I keep that one, but I can't be the 3. I keep the 3, but I can't be the negative 1. So now on this one, I'm going to put the 4 over 1. I'm going to give him an x plus 1. The only reason I wanted to do this one is because it has a shark. So I have 2x, and then I have minus x minus 1. And that's the kicker, so make sure you're good there. Equals 2x minus 10. The two x's are going to cancel each other out. I'm going to add the 1 over, so I get negative x equals negative 9. Oh, hold on. No. I forgot to distribute the 4. Dang it. All right, let's back up. See, this is why I need to do this in front of a class. Okay, let's try this again. 2x minus... All right, I was so worried about the shark, I completely forgot about distributing the 4. So minus 4x minus 4 equals 2x minus 10. So sorry. The 2x's still cancel. I have negative 4x. I'm going to add the 4 over, and that's a negative 6, and then divide and reduce and get a 3/2, which I can keep. The only thing I couldn't be is a negative 1. For number 14, I just want to, just try to cover all the bases. I would put this whole thing over 1 and give him an x minus 3. So that gives me x squared minus 9 equals 9. This is quadratic, but if I subtract that 9 over and get it equal to 0, I have x squared minus 18 equals 0, which are not squares. It's not a trinomial. But what I'm going to do is just add the 18 over and root both sides. But when you root both sides, don't forget you need the plus or minus. 18 is 9 times 2. So that'd be plus or minus 3 root 2, which I can keep because the only thing I couldn't be was a 3.